lesson 11.4, integration by parts. So in 11.3, we were revisiting the substitution rule, which was all about undoing the chain rule. 11.4, integration by parts, is all about undoing the product rule. So the product rule from chapter 2 would tell us if I'm multiplying two functions together, then the rule is 1d2 plus 2d1. The product rule is so much fun. So I'm sorry, Cedar's class, if you didn't get the rhyme. We learned a couple of rhymes in my class. Okay. That aside, we can rewrite this in terms of integrals to think about the antiderivative piece of this. So if I know my derivative is this little rhyme, 1d2 plus 2d1, then if I take the integral of that, I should be able to then find my antiderivative, which would be the product. Yeah? So in one way, we're taking the derivative, and in the other way, we're taking the antiderivative. All right, so by properties of integrals, I can separate those into two separate integrals since I'm adding two pieces together. Okay, so I can make them become two separate integrals. Then the integration by parts rule actually has you move the second integral to the other side by subtraction. So we subtract it to the other side, f prime of x, g of x, dx. That's where this rule in the gray box comes from. Okay, so it's all about just recognizing that we've taken the derivative of a product. Now we're going to go backwards. So we're going to take the antiderivative of this 1d2 plus 2d1 and manipulate it a little bit so that we end up with this rule that's in the gray box. Okay, right here. This is our integration by parts rule. Now this formula can also be used with different notation, which is a little bit easier to use in terms of u's and v's instead of all these f of x, f primes of x. So just so you understand where all the parts are coming from. So f of x is your u. Okay, so if u is equal to f of x, then du is equal to f prime of x dx. Okay, so all we've done is taken this du on dx, which would be the derivative of u in terms of x, which would give us f prime of x, and then we've multiplied the dx up to just give us a du. Okay, and then that is all of our parts right there in our formula. And then, of course, they've done the same thing with g of x, but g of x is v. So if I take the derivative of g of x in terms of x and then move the dx up, then I would get g prime of x. So that would be these parts in the formula. So basically, when we're doing integration by parts, we're going to need four pieces every single time. We need a u, a du, a v, and a dv in order to fill in the formula. Okay? All right. So the idea here is to get ourselves to a simpler integral than the one that we started with. So even though this looks a little bit ugly and complicated, once we have our four pieces and we fill it into our formula, hopefully we'll get down to a simpler integral. Okay, now for you guys, we haven't done chapter 8. Now some of you might have done some investigation on your own. Okay, you're not responsible for e to the x and ln x at this point. However, for this lesson, you actually need to be aware of their derivatives and antiderivatives to understand how this integration by parts actually works. So I'm giving you the rules. Follow along on the examples. It shouldn't be too bad. So here are the rules. If the original function is e to the x, the derivative of e to the x happens to be e to the x. So it doesn't matter if you're taking the derivative or the antiderivative, both are e to the x, which you will see in mid-June if you take the desire to watch the chapter 8 lessons. Now ln x, if you weren't aware, ln x is log x with a base of e. Okay, it's the natural logarithm. It's used so often it has its own special name so that you don't have to write log of base e each time. Okay, if the original function happens to be ln x, then his derivative is 1 on x. Okay, if you know the derivative, then of course the antiderivative will be ln x. Okay, so just a couple of little notes up. Yeah, we'll just go with that. We'll look at the ln x a little bit more in one of the examples ahead. Okay, so we're going to start with example number 1, where we have x and e to the x dx being multiplied together. So we do have a product. So this is the first thing I'm going to recognize, is that I have a product, two pieces being multiplied together, an x and an e to the x dx. Okay, so I am going to assign u as x, and then I'm going to need to take the derivative of that. So du dx, so the derivative of x is 1, and now I need that to be written as du. So this is different than the substitution rule, where I wanted dx isolated. Now I want du isolated. So I'm going to multiply the dx up. So this is the trickiest part about integration by parts after substitution, is recognizing who you do what with when. Okay, so then the other part will be dv. So e to the x dx is the other part of the product. And then the antiderivative of e to the x is e to the x. Okay, so you have to take the derivative of the u. You need to take the antiderivative of the v. All right, step 2, we're going to put this into our formula. I'm a little bit crooked today. Okay. Trying to find everything. Okay, number 2, step 2, my formula is u dv is equal to u multiplied by v minus the integral of v du. And then you get to substitute in everything we just found. Okay, u dv should look like my original question. So I have x e to the x dx is equal to, we said u was x, and the antiderivative of e to the x is e to the x, minus the integral of v, which is e to the x, and du, this guy right here, is dx. So that then makes this second integral in terms of x. We're not done. Now we have to integrate that second piece. Okay, so this part right here, every single time you fill in your formula, needs you to integrate. So the antiderivative of e to the x is e to the x. Okay, so you have to take that antiderivative. And then you write out your answer. Because this is an indefinite integral, then we need the important plus c. Minus, so the integral of e to the x is e to the x plus a constant of c. That's it. That's the rule. Okay, now how did I know that x was going to be u and dv was going to be the other piece? That's the part that's important. That's why I wanted to look at the exponential and the logarithms in this lesson, because there's a rule for order. Who gets to be where? Okay, it's called the late rule. Okay, in like quotations. How do you decide who gets to be u? You go in this order. If it's logarithmic, the logarithmic guy gets to be u. If there's no logarithmic in your function, like in this example number 2, we don't have a log. Okay, move to the next one. Algebraic comes next. So algebraic is your x, your 2x, your 5x, x squared. Okay, so this guy, x, will then be my u because he's algebraic. And then trig, So trig comes after algebraic, so he has to be my dv. In the previous example, I had e to the x, that was exponential. Okay, so this is why in the previous question, I chose u to be x, because I already knew the rule. Now you know the rule. Okay, so here we go. Let's erase all this funky stuff. Step 1, u is x. Du dx is 1. So we now know that the derivative of x is 1, and we manipulate, so du is equal to dx. And then the other part is dv. dv is the trig piece plus the dx. So cos 3x dx, and we want to integrate that. Okay, so the antiderivative of cos is sine of the argument divided by the coefficient, or multiplied by 1/3. Okay, now we have all our pieces. Let's go ahead and put it into our rule. So we have u dv is equal to uv minus the integral of v du. Plug in all your pieces. So we have x cos 3x dx is equal to x times 1/3 sine 3x minus, now we're going to have to integrate this part. We have a 1/3, I'm just going to put that in the front because it's a constant, sine 3x dx. And what I need to know to do my next step is, what is the integral of sine 3x? So the antiderivative of sine is negative cos of the argument divided by the coefficient on that argument. And then we can write out our answer. So this is equal to, I'm going to put the 1/3 in the front, just tidy it up as you're moving through. 1/3 x sine 3x, that's the uv, minus, we're going to have a 1/3 and a negative 1/3. Oh, we have a negative 1/3 because we're subtracting. So this is going to become a positive 1/9 cos 3x plus c. Voila! There it is, integration by parts. Very fun. Okay, example 3. I would like you to set up, before you press start on video number 2, the u dv's. Set up your 4 parts. What is it that you think needs to be for each piece? I'll see you back in